So let's practice predicting and writing non-ionic equations for reactions of acids. In this case, we're going to look at the reaction of an acid with a metal oxide or a metal hydroxide. As I have mentioned earlier, the oxide or the hydroxide can react with the H plus from the acid to give you water. Okay, so acid plus metal oxide or hydroxide will give you water, and the other product would be a salt. That would be the cation from the hydroxide and the anion from the acid. So let's take a look at this example right here. HCl plus sodium hydroxide. HCl plus aqueous plus sodium hydroxide yields, well, you see the H plus here and the hydroxide there will give you HOH or H2O. That's water, and water would just, the water molecules you make will just be join the rest of the solvent. So we put an L there because the solvent is a liquid. And then the other possibility, okay, so you have your H plus and your hydroxide, and then your sodium and your chloride would give you your ionic compound, your salt, and ACl aqueous, and that's already balanced, so that's your molecular equation. How do we write the, and you know that sodium chloride is soluble in water. It's got a sodium compound, so we put aqueous there, right? So how do we write the net ionic equation for this? Well, you look at your HCl. You know this is a strong electrolyte. It's one of the 6 strong acids, so I have to split that up into H plus and chloride, because it's an aqueous solution. Sodium hydroxide is an ionic compound. In aqueous solution, I have to write it as separate ions, sodium ions plus hydroxide ions. Okay? And my products would be H2O liquid. I don't do anything extra with that because that's a molecular compound. It's a non-electrolyte. It's part of the solvent, so H2O liquid. But sodium chloride, I know, is a strong electrolyte, so I have to write that as Na plus aqueous plus chloride aqueous. Okay, so this is what you would call your ionic equation. And to get my net ionic equation, I have to get rid of my spectator ions, which is sodium. Okay, yes, I see it on the left and I see it on the right. And chloride, I see it on the left and I see it on the right. And so what I have here is I have H plus plus hydroxide. That's the only thing left on the left. Aqueous gives you liquid water. This is your net ionic equation. This is pretty much what you get every time you have a strong acid and a metal hydroxide. Okay? In aqueous solution, you have H plus plus hydroxide yields H2O liquid. Alright? Let's take a look at another example here. Let's look at the second one. Barium hydroxide plus H2SO4. So I have barium hydroxide plus H2SO4. Okay, so the H plus from the H2SO4 will combine with the hydroxide to give you water. And the barium and the sulfate will combine to give you barium sulfate. Now, you have to, so this is aqueous. This is aqueous. Water is a liquid. Barium sulfate. You go back to your solubility rules and you'll find that barium sulfate is in fact insoluble in water. So I have to put an S there to indicate that that's going to come out as a precipitate. Okay? So that's my molecular equation. I just need to balance it. So to balance it, I'm going to need a, let's see, 2 H pluses, 2 hydroxides will give me 2 waters. Okay? And 1 barium, 1 sulfate would give me 1 barium sulfate. So this is my molecular equation. And you should be able to show, I'll leave it up to you to figure it out. that your net ionic equation and your ionic equation are the same in this case. You have barium ions plus 2 hydroxide. I'm just going to leave out the AQ and the L and the S labels, okay? Plus 2H plus SO4 2 minus. Notice your sulfuric acid is one of your 6 strong acids, so I have to separate those into ions in aqueous solution. Yields 2H2O liquid. Okay, I'm just going to leave out the labels. Plus barium sulfate solid. This is your ionic equation, and that is also your net ionic equation. Okay, that's also your net ionic equation because there are no spectator ions that you can cancel. Let's take a look at the next one. Calcium hydroxide plus acetic acid. Calcium hydroxide plus acetic acid, HC2H3O2, aqueous. So my H plus from acetic acid and my hydroxide from calcium hydroxide will give me water, liquid, and then my calcium and my acetate would give me my salt, Ca. And my acetate's -1, calcium is +2, so that means calcium acetate is Ca, parenthesis C2H3O2, 2 aqueous. You have 2 acetates for every calcium. And so to balance this, you can say, okay, I've got 2 hydroxides here. I'm going to need 2 H plus to neutralize that. So that will give me 2 waters. So this is your molecular equation. Okay, and your ionic equation would be, okay, I'm going to say calcium hydroxide. It's an aqueous solution, so that's an ionic compound. I have to write it as separate ions. And I'm just going to leave out the labels now. Plus 2 acetic acid, HC2H3O2 aqueous. Okay, acetic acid is a weak acid, so I should not split it up into ions. Most of those molecules are going to remain intact in aqueous solution. So I'll write it as is. Yields 2H2O liquid plus calcium should be written separately. Calcium acetate, this is an ionic compound, so that should be written separately. Calcium ions, aqueous. Let's just leave out the AQ label here to make things simple. You don't have, you can keep it there if you want for completeness. I just want to make it easier to read. Calcium ions plus 2 acetate ions, 2C2H3O2 negative. Okay, so this is your ionic equation. And you'll notice your only spectator ion here is the calcium, so that's the only thing you need to get rid of to get the net ionic equation. So your net ionic equation will be 2 hydroxides plus 2 HC2H3O2 yields 2 waters plus 2 acetates, 2C2H3O2 minus. This would be what you would call your net ionic equation. Okay, so finally, last example here, calcium hydroxide solid. This time, you're dealing with a solid calcium hydroxide and you add hydrochloric acid to it. So the hydrochloric acid is an aqueous solution, but your calcium hydroxide is a solid. So your calcium hydroxide solid plus HCl, aqueous. Your H plus combines with the hydroxide to give you water. And calcium is +2, chloride's -1, so that means calcium chloride is CaCl2. And based on your solubility rules, you should know that that is soluble in water. water, liquid, okay? And so to balance it, I have two hydroxides here, so I'm going to need two H pluses to make two waters from that. And calcium is balanced. I've got two chlorides on the left, two chlorides on the right. This is my molecular equation. Acid plus base gives you salt and water. Your salt in this case is calcium chloride. To get the ionic equation, you'd say, okay, this is calcium hydroxide solid, so I cannot split that up into ions because it's not an aqueous solution. HCl is a strong electrolyte. In aqueous solution, it has to be split up, so I have 2H plus 2 chlorides. Gives me 2H2O plus calcium chloride in aqueous solution, so I have to separate that. That's an ionic compound, calcium plus 2 chlorides. This is my ionic equation. And finally, to get your net ionic equation, you need to cancel your spectator ions. Your spectator ions here are the chlorides. So you say calcium hydroxide plus 2H plus yields 2H2O liquid plus calcium ions. This is your net ionic equation. Okay?